Hello, I've got an integral that I'm trying to figure out here. It's the integral from -1 to 1 of the function 1 over x squared. So my normal process for this is to think of this as x to the -2 and just apply the power rule. So add 1 to the power, divide by that number, I get -1. So I get x to the -1 divided by -1. And that's -1 over x. So let's see what I get from that. If I plug in +1, I get out -1 over 1. And then I do minus. When I plug in -1, I have -1 over -1. So I got -1, and I've got 3 negatives here, so that makes another -1. So I get -2 for my answer. Now, let's think about what the graph of 1 over x squared looks like. 1 over x squared has a vertical asymptote at x equals 0, like this. And on the right-hand side, when x is positive, it looks kind of like 1 over x. On the left-hand side, when you plug in negative values for x, you get positive y values, and it's going to be symmetric about the y-axis. So the graph looks like this. So what I did was I took the area from -1 to 1, so this area, and I got out -2, even though this area is all above the y-axis. So pause for a second and think about what might have been wrong with what I did here. After you've thought about it, hopefully, well, it's not obvious what's wrong here, but you do have this asymptote. There's some kind of problem going on here. What happens is the fundamental theorem of calculus that I used to just take the antiderivative and plug it in and assume that that's going to get me the correct area does not work when the function is discontinuous on some piece of the interval. So since this is discontinuous from -1 to 1, that can cause problems. In this case, it causes a problem because the discontinuity is infinite. You're having this vertical asymptote. So what I need to do, if I want to calculate that area, I need to break this up into 2 pieces. Get the area on the left and the area on the right. In this particular case, the function is symmetric. So I can just do 2 times the integral on the right, the area on the right. So this does not work. That's incorrect. Should not get -2. And the way I'm going to remedy this is to do 2 times the integral from 0 to 1 of 1 over x squared. But still, my function is not defined at 0. So instead of being able to just do something directly here, what I'm going to have to do is set up kind of a dummy variable between 0 and 1. So I'll put it here for now. And then I'll calculate the finite area from a to 1. And then if I let that a start scooting towards 0, then I'll get better and better approximations of what my area actually should be. And if I take the limit as a goes to 0 from the right, I'll get the exact value that I want. So that's what I'm going to do. I'm going to take the limit as a goes to 0 from the right of the integral from a to 1 of that function. And then we'll see what happens here. Notice it's possible that I'll get something infinite because these functions are this function is shooting up to infinity on the right and the left. But it's also possible that I'll get something finite that we can define nicely. Let's just see what happens. So the antiderivative again is negative 1 over x. What I get when I plug in my bounds is negative 1 plus 1 over a, minus a negative there. As a goes to 0 from the right, what's happening to that fraction? As the denominator shrinks down to 0, this is getting infinitely large. So this is 2 times negative 1 plus infinity. So this is going to infinity. When your area turns out to be infinite, that means it's larger than any finite area that you can define. Then one way to describe that is to say that the area is infinite, or it equals infinity, or you can say that this integral is divergent. Sometimes there are functions that have a vertical asymptote like this, where they actually converge to something finite.